Alright, hopefully this is going to be a quick video, but I thought I'll just do it for funds. But anyway, it's kind of like a mailbag video. So a while ago I bought a whole pile of these off the internet. They were like, they're a whole bunch of ceramic logic ICs, and I thought, wow, that'd be kind of cool. I'll get lots of really cool old logic ICs, but pretty much every single one here that I can see is a cmos 4027. So I didn't really get the range that I was kind of hoping for, and I have no idea if these work. Like, these are kind of, someone was using them. This one's not. This one's a, oh no, it is a 4027. There is one or two in here that are not 4027s, but pretty much everyone I've looked at isn't, and they're in pretty rough condition to be honest. So I thought we'll just do a quick video where we'll try one and we'll see if it actually works. I do have a little device specifically for testing these kind of ICs, and if I put it in that device it would come up and say whether or not a particular one is working, which I might have a go with, because obviously I'm not going to test a whole lot individually. But the question is, what is a cmos 4027? Well, it is a dual JK flip-flop, and actually this is kind of useful because I'm kind of wanting to use one of these at some point. I don't have a better picture. So this book here doesn't have a 4027 in it, but it does have the TTL 7473, which actually is just kind of funny. So the other thing I got today was a whole pile of vintage electronic bits and pieces, and what they have is, so these kind of things. So there's a whole bunch of resistors. I don't know how old these are. They are probably, it says year, month. Well, that's useful. If that's actually, no, that can't be true. What does this mean? Year, month. Does this mean 1979? I guess that means 1979. No, that doesn't make any sense. You can't have the 20th month of, well, I don't know what that means. Well, that could be potentially true, I suppose. So mainly here there's a whole bunch of resistors and some old school capacitors, and some more funky cool resistors, and definitely some old school. Well, that's obviously not year 37. I don't think this is a code for the year. Because that would be weird. But look at this, they have an individual packet for a BC 107, and I was just reading about one of these recently. These used to be the bee's knees. These transistors. I've got a couple of packets with just that. Look at that, it's amazing. Absolutely amazing. Right, but there's a few more things in here. So there's a bag of these, and this one is pretty cool. There's a whole bunch of relatively standard. One of these is the 2N3906 and the other one's 2N3904, which I think is general purpose signal transistory things, PNPs and NPN ones. But here's a little tiny bag, and inside of here are some old transistors, but like the old school. Look at this, look at that, neat. Never tried to use one of these, but some of these are actually 2N222s. So one of them was. So that's like my little collector's thing, because I don't have any 2N222s. That's a 2N2907. But one of them definitely was the absolutely standard one nowadays. Can't actually read this one here. So this one here is a 2N222. So it's exactly the same as, well, not exactly the same, but it's the somewhat older version of that one. So that's the 2N222 as well. So that's kind of cool. But that was not what I was actually going to talk about. I don't know what the other what this one is. You can barely read it. It says BF458. So there you go. I was kind of hoping they were a bit more older than that, because I had an idea for what to use them for, but that's alright. But the last thing in the box, there's another, someone actually used one of those, is this, which is a Dick Smith Fun Way into Electronics. Don't worry, we're going to be doing some Fun Way into Electronics soon. It's a touch switch, but it actually has in the packet an actual TTL 4743. There you go, it's got that JK flip-flop that I was just mentioning. So move those things out of the way. So my picture of it, where did I put it? So the closest thing I could come up with is, so that was the IC in that little bag. So that's the IC in here. And it's just that hopefully that picture might help sort of understand what it does. So it has two inputs, J and a K, and two outputs, and it's a clocked flip-flop. So it's not like that simple RS1 that I keep using all the time. This is slightly more advanced, and it's got this clear thing. In fact, this is exactly what I want to use. So I don't know if this one's exactly the same, if it has a clear. We're just going to find out, and we'll just see how it works. So first off, we'll take one. Let's just pick up which one is not too terrible. Well, some of them aren't. They get a bit of oxidation or corrosion or stuff on the legs. Like, I honestly don't think this is going to work that well. Where did I put my little chip squasher? We put the chip squash. Put that in there. Is this the best one to choose? Well, I guess we'll be finding out. All right, so that can go there. This is my left in the sun. What should we call it? Board, prototype board. Just go in. All right. So that feels a bit weird. Why is it not going in properly? Is it the board or is it the IC? Oh, it doesn't want to go in at all, does it? Okay, well, let's just try a different one. What's up with that? Maybe they won't go in. Maybe they've got slightly different. No, that one's really, really not too good. That one's all over the show. Oh my gosh. So I think the person who had these didn't actually want to use them for anything electronically. They wanted to use them for decorative purposes, to make art out of them. In fact, there was a pile of these and a big pile of these EEPROM chips with the little windows on them, which I can guarantee I'll never get around to using for anything or even trying. But you never know. So I might use those for an artistic endeavour. They're on the floor. I'm not going to get those out right now. Oh, they just won't go in the holes. So first problem is, why won't they go in here? Is this actually, hold on. I'm going to try this little board here, which has, this is coming up soon, don't worry. Is it actually the board? It is the board. What's up with this? Well, okay, we'll have to take these bits off. Sorry, shouldn't pull it out like that. Alright, we'll just use this board. Now we have a lot of space. Okay, so let's quickly do this. So we need a couple of wires to hook up. So I've got it the wrong way around. It comes out easily enough. It does feel very scrunchy when it goes in. Alright, so looking at my little picture, this is 5 volts. It just didn't go in very well at all. Alright, so that wire's gone in, and we'll pick up this little random wire sitting here on the desk. I feel bad now because I pulled the other thing apart. I pulled something that was on here. I pulled out my little my A-stable multi-vibrator that I put on there for no reason as my reference one. I just pulled that all apart just to put this on, because they're pretty easy to make. I've made a couple of them now. I haven't talked about them on this channel because I really want to talk about A-stable multi-vibrators and just go through and explain it. So that's the best way to understand things, is to explain it to other people. Right, so that's actually the wrong thing. I was looking at the wrong IC. We're looking at this one here. Okay, flip-flop. So let me just see how this is going to work. Well, we need an output. So we will put this little, where did I put my relatively appropriate resistors? So that can be the output. It can just go there, and we'll just put that. It's not going to go in the hole. Alright, and then we need a wire. Which wire should we use? We can't use that wire. So looking at this, we have Q2 and not Q2. So we'll just take from Q. So actually, we can do this relatively neatly. So what I should do is not put that in, is put that in first. There's a helicopter going overhead, which makes me think of that that Learn Electronics channel, which I quite like that guy. He's quite cool. But he always has trains going by in the background, and I'm like, oh my gosh. It's very American, I think, to live in a place that's next to a train line. It just seems that way. Like there are people who live in New Zealand who live near the train line, and so you can probably hear the train going past. So but it just seems like the kind of thing that if you lived in the States, you'd live next to a train line. All right. So we've got that one. We've got a reset and a clear. So what's the difference between a reset? All right, I'm going to take this back so I can just read over it. Okay, so it says here, if J and K remain grounded, clocking does nothing. All right, so well, the first thing we need is some buttons. And of course, I don't have the buttons on the desk. Oh, no, I do. I have a button. I have 2 buttons. How many buttons am I going to need? Well, these things have to go... Hold on. Alright, so first off, we're going to have to do a lot of pull down resistors. So there's a 10K going to ground for J1 and a 10K going to ground. That's not really going to work, is it? Because I'm not going to have enough room to put the wire in. We're not going to chop the legs off today. Sorry, it's just not going to happen. Alright, so there we go. So there's 2 10Ks, pulling them to ground, and we have a reset, and we better do the whole thing, right? I think. I've got this upside down. Oh, of course, I've gone and turned the picture upside down, and now everything is wrong. So, actually, it's not too wrong there. So... we're not going to worry about the not Q output. Though maybe I should, because there's probably, I think there's a disallowed state which will mark up the Q and not Q outputs. Oh my gosh, there's a lot of things here, isn't there? Like this one's a full featured IC. It's got a set and a clear and a reset. Hold on, I don't understand what they all are. So there's like a non-clocked one, and then there's a clocked thing. So you can make it go to one state at any point, or you can make it go to one state on the clock pulse. And so but I don't understand what the difference between reset. I'm gonna have to read this whole thing. All right, let's just put all of these wires. So everything's being pulled down right now. So if everything's being pulled down and we turn it on, what should the LED do? The LED should do nothing, right? Okay, so let's just test this. Alright, well, first off, I'm going to push. That one's going to go to there, and then that's going to be a pull. I've got that in the wrong place, but that's okay. That's too small. I've got everything's the wrong size. Well, that one. So this button here is going to be connected to. What's that connected to? That is connected to the wrong one. Okay, this is. Oh, I should have put it the other way around. It's going to get super confusing now. So I want this connected to J. This is the J input. So this button is for J. And we'll just put another little wire to here. I don't know how this is actually going to work. We're halfway through my half-hour allotment. So things could be going pretty bad relatively soon. Good news is I found my oscilloscope, so we can go back and have a look at my little 555 thing. So this is going to be my clock pulse I was expecting, which might make it a bit jittery. So which one's the clock? That's a good point. Where's the clock pulse of this thing? Oh, right, gotcha. So what I thought was CL for clear is in fact CL for clock, which makes a lot more sense. So, and I've got these wired up wrong again. Oh my goodness. Alright. I knew there was something funny going on here. Alright, that one goes there. Oh no, 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 no. No, I have it right, I have it right. I keep forgetting about that Q, the Q naught. So the clock one is that one there. So this is going to be my clock button. This is J2. And then I've got reset and set both pulled to ground. So is that what I want though? If J is positive and K is grounded, clocking forces Q positive and Q to ground. If J is grounded and K positive, clocking from Q to ground, clocking forces Q to ground and Q positive. If if J and K are both positive, clocking alternates the J and Q states. Right. In direct mode, a positive set input forces Q positive and Q to ground. A positive set blah 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 blah. Should both set and reset simultaneously go positive? Okay, so basically, if there's a positive input, so if there's a high input on either to the set thing, then Q will go on, and if there's a high input to the reset, then then Q will go off, will go low. And if they're both high, then Q and not Q will both be high. So that's like the illegal state, is to have reset, which is kind of like the standard RS gate thing. Alright, this is usually a disallowed state. Alright, okay. So the direct input. So that makes sense. So this is quite a useful little device. It's got that neat little feature that if you have both, we do really need another button, don't we? I mean, I don't know if I have it. I have one more button when its legs are squashed. So I forgot all about the fact that you needed buttons. I thought, well, I'll just, oh, there we go. There's one. I put a whole pile of buttons sitting on the table. So we can put in one more button, and this is going to be the, I'm going to keep everything on the same. This is going to be the K input. So we're not going to worry about the non-clocked inputs for now. Because like if the main part works, why would the other parts not work? That's what I think. All right. Well, it doesn't matter. These are J or K and J and K, and this is the clock button. So if I turn it on, the LED should not come on. All right. But if I hold down what I think is J, and then I clock it, then the LED should come on. So nothing should happen when I press the buttons now because there's no clock pulse. So if I hold down that one and then I clock it, nothing happens. Have I got everything actually connected up? I think I have. So there's always a chance that this just does not. Okay, hold on. I've probably wired it up wrong as well. No, I haven't wired it up wrong. I'm really paranoid because I keep swapping this around. And I have wired it up wrong. So that one is actually the set. So I want that to go. Wow, hold on a second. If this is set, and then I pull that high, shouldn't the LED come on? That's the big question. Is this actually working? Is this wired up correctly? That's wired up, that's wired up. What if I turn it around and put it onto that? So it is pulling it to ground. Alright, so that's awfully bright, isn't it? Do I have like a oh, we just use a 10K one. That's too bright for my eyeballs today. Alright. So that's 10K. My goodness, they're so efficient these days. Alright. So I'm going to put that one actually over. And so I'm going to turn that one back around because I kind of want to do it this way. Alright. So we'll try this again. So I'm just going to double check that this is in fact the clock pulse. So clock 2. Alright, so if I hold down this one and clock it, nothing happens. And if I hold down this one and clock it, nothing happens. I'm going to have a test. I'm going to test my buttons because I can't really think of what else to do at the moment. With another green LED. It's all going to be green LEDs today. And we've got to have a different colour. We're going to get confused. So we're going to get a nice little yellow one. Oh, there's some buttons in here. And we'll just test it with this one. Because I'm just a bit worried that the what was I going to say? Here we go. That the buttons don't work for some reason. I mean, I'm not. Why would I be surprised if these things do not work? All right. Well, let's just test this button. So, what? Really? No, wrong way around. Okay. Oh, these don't go anywhere near as bright. Okay, let's just try a different one. You've got to be able to see it on the camera. I'll go with the trusty blue. Oh my goodness, I'm fluffing around. Alright, what we're going to do is we're going to quickly test the buttons, and then if all the buttons work, and everything seems to work as I think, okay, that one works. So that one was the clock, so that can go back to there. Next one is going to be this thingy, so that one can go there. And that one's not actually doing anything. So what have I done wrong with that one? I put it on the wrong. No, it's still not working. Well, that's encouraging. Did that actually work? I can't even remember. Well, that's because it's the wrong button. Now that's why. You're gonna pay attention. Oh, that's upsetting. I was kind of hoping I'd just wired up the buttons wrong. So that one's wrong. That one's right. Alright. And then the black wire. Like, why would this be the problem? Alright, that all works. So I'm going to actually move these wires onto set and reset. So I'm just going to completely and utterly ignore the JK part. So if it did work, like, I would think that pressing these buttons would turn this on and off. Like, this would act like a standard sort of RS latch. So that one doesn't seem to work. So we'll try a couple of other ones. And see, well, look at that. One of the legs was squashed. I think that's probably the problem. Look at that. Oh my goodness. And it's like one of the important legs. No, it's not one of the important legs. It's one of the not important legs. Still, it probably was a bit inconvenient. Maybe only half of it is broken, of course, and so there's two. This is a dual flip-flop. So maybe the other side actually turns out that that one worked fine on that one, even with a broken leg. So that one goes there. Where's that little leg squashy thing? Alright, we'll try a couple and then we'll just give up. It's probably that the legs are just too, like, I don't know if it's oxidation. I'm just going to say that because it sounds like the smart thing to say. Yes, it's definitely oxidation on the legs there. From being so old. Like, I don't know how old are typical ceramic ICs. It's a shame. There must be like at least 100 in there. Alright. So did I squash any legs doing that? And everything's lining up properly. I think everything's lining up properly. That's going into the right place. That's going into the right place. And, well, obviously I've got that turned on. Again, nothing is happening. So, do none of these work? There's a good chance that this is in fact the case. Maybe I do actually need my fancy IC tester tool. And we can get that out the next time when I do my testing over the my pretend 555 thing. So I have decided pretty much, like, guaranteed that we're going to be doing some more joystick controller fun up next. So, but there's a project that's going to be the one after the joystick thing, which I want to use this exact kind of flip-floppy latch, this JK latch, for hopefully it will all make sense. So okay, well the other thing we could do is, instead of putting this onto the Q output, this is obviously not changing anything. Well, I could just move it across. Well, because I use that kind of wire, it's not helping at all. Alright, well, where is 3 minutes left. So I thought this was going to be short. I'm actually going to wire it up to there, and then we'll wire this one up to where did I keep to the Q output. So there's a Q and a not Q. Those are the outputs. So they should be complements of each other. So when one is on, the other one should be off. And that's probably the easiest way to testing if these things even remotely work, is to do that. And so they don't appear to work at all, which is sad. I mean, given how old they are and given how they've been mistreated, it's highly. Well, we could do one thing. We could try really quickly. Have I got anything abrasive that I can use? We have a file. We'll just file down the legs a bit. That feels like it can't be very good for an IC to be doing this. Oh, and I bent one of the legs. Oh, I bent a lot of the legs. Well, we'll just throw that one away. Let's pick up another one that doesn't have its legs bent. And that one's got really legs. We'll try this one, and we'll try this one again, and we'll just sort of. I think it's just better to go one way. That's looking at kind of sparkly. 2 minutes left. We can do this. Is that kind of better? Alright, we'll try and do the inside as well. And this, like, that feels like you're going to generate some static electricity or something and really blow it up. Like, you know, these are CMOS things, and they're old style CMOS, so I don't know if that makes them any more or less or more prone to static shocky stuff, but I personally have never had any problems at all with anything. I'm going to turn it off before I plug it in. So let's just turn this one back on. No, neither of these actually come on. So I think the chances of any of these actually working are slim to none at all. So we'll get one from the bottom, and then we'll finish there, and we'll say, what's that thing? Wow, it's like you can see the inside of that one. So that one's had a bad day. But there's another one. So someone's been taking these things apart. Oh my goodness, it's like a horror story. Alright, take that one out with my hands. They do pop out once you get them in, they come out pretty easy. Alright, and the last one. What if they're just back to front? What if they're not actually wired up the way the book says? What if I got that wrong? Alright, we need to squash it. Well, this has been an exciting video where absolutely nothing has happened. So I'm just going to hopefully I do actually have some. They weren't the kind of thing that I thought was any use, so I haven't really. Well, that one doesn't work either. Nothing is happening. Alright, thanks for watching. I'll try and dig up some ones that actually work for the next project. Bye!